Hello, everyone. Today we are going to start our topic. We're going to continue to our topic, budgeting. We are still on budgeting, okay? And today we're going to start with correlation. Yeah. So we are still on budgeting. But today we're going to start with a new topic called correlation. Correlation. So what is correlation? So correlation, we say it's said to be when two variables are correlated to each other. The changes in one variable is accompanied by the change in another variable. Then we can say these two variables are correlated. Let me repeat. Correlations here means we have two variables. A change in one variable is accompanied by a change in another variable. Then we can say these variables are correlated. There's a correlation. But if a change in variable does not affect a change in another variable, we can say there is no correlation. Okay, let me give you an example to the definition of correlation. Okay, let's look at hours worked. Right. Look at hours work. Hours worked and rates pay per hour. So hours worked and rates pay per hour. Hours work is one variable, rates pay per hour is another variable. The more hours you work, the more money you make. The less hour you work, the less money you make. So we can say these two variables, they are correlated. There is a correlation. Okay, let's look at another example. Speed and time. Speed and time. The faster you go, the lesser the time. The slower you go, the more the time. So we can say the changes in one variable will affect another change in another variable. Then we can say they are correlated. This is what we mean by correlation. Okay? So now if we understand the concept of correlation, and let's look at the type of correlation. Okay? Type of correlation. We have two types of correlation. Type of correlation. We have two types of correlation. One, we have positive, and two, we have negative. We have two types of correlation. We have positive correlation and we have negative correlation. Don't rush, take your time. What is positive correlation? We already learned that correlation is we have two variables. The change in one variable will affect another variable, right? Now, if these two variables will go on the same direction, then it's a positive correlation. If these two variables, one is going upwards, the other one is going downward, they will say it's a negative correlation. Is that okay? Let's give me an example. Let me give you an example for positive correlation. We said correlation is said to be positive when the two variables move to the same direction. Correlation is said to be negative when these two variables move in an opposite direction. Now, let's look at ice cream. I'm selling ice cream in a hot weather. Selling ice cream in hot weather. So the ice cream sale will go up while the weather match with the weather. So both of them have a positive correlation. Okay. Spending with credit card. The more you spend, your credit card goes up. The more you spend, your credit cards go up. So both going in the same direction. The spending and the credit card are going in the same direction. Demand and supply. If demand goes up, supply goes up, then there are positive correlation. If demand goes up, supply comes down, then they say negative correlation. Hope we get the concept of the type of correlation, the positive correlation and negative correlation. Positive correlation when these two variables move in the same direction, but if they are going up, they are going up. They are coming down, they are coming down, both direction. Negative correlation when these two variables are going in opposite direction. One is going up, the other one is coming down. One is going up, the other one is coming down. That is negative correlation. Okay, you get that? Now, I haven't done the type of correlation. I have degree. Degree of correlation. The degree of correlation. What's the degree of correlation? We have three degree of correlation. One, we have perfect correlation. Perfect correlation. We have partial correlation. And three, no correlation. We have three correlation. We have perfect correlation, we have partial correlation, and we have no correlation. What does this mean? Let me do a diagram for you. I have this diagram, and I have this variable here, this variable here, this variable here, and I have my line touches all these variables. Then this means the variables are strong, so we have perfect correlation. This means we have a strong correlation. There is a strong relation between these variables. There is a strong relation, then it is perfect. This is a diagram for the first one, perfect. Perfect correlation. Okay, the other one, let's have the same diagram here. Okay. And this is going this way, and this way. And we have this line, touches like this. Then something like this. So we can say this is the two partial correlation, not two perfect, partial correlation. Okay. And where there is no correlation, where there is no correlation, how do we have this? No correlation. We have this here, we have this here, we have this here. There is no correlation. No correlation. That the variables does not correlate. One change in variable does not affect change in another variable at all. There's no correlation. But when one variable affects the change in another variable, there is a correlation. What can be the correlation? Correlation can be positive or negative. Okay. This is the idea of correlation. Now, how do we calculate the strength of relation, which is our nightmare, how to calculate the strength of correlation? So let's do the formula. Let me give you the formula on how to calculate the strength of correlation, and then we move to practical examples. Okay. I have a question here. So how to determine strength of correlation, which we can call R. How to determine the strength of correlation, we can call this R. So basically, we are looking for R. We're making R the subject of the formula. There is a formula on how to calculate the strength of the relation, which is the R. Okay, so we call this R in mathematics the coefficient. All right, so the formula is R is equals to, don't worry, the formula is is confusing, but don't worry about it. We explain the formula and we do a question. R is equals to N. N mean the number, okay? And sum of XY. So we have two variables. What are the variables? X, Y. One is a dependent variable. The other one is an independent variable. So one is dependent on the other. Okay, minus. Now we go to the variable sum of X, sum of Y. We've done statistics. This sigma means sum of X, sum of Y. Okay. Divide. Okay. Now we have our square roots. In the exam, don't worry, this formula will be given to you. You just need to understand how to apply the formula. This formula will be given to you. Don't worry about it. So, and here we have N here, sum of X square, sum of X square minus, in brackets, X, sum of X all square, and bracket open again, N, sum of Y square minus sum of Y all square. So these are our formula. Okay, so N, sum of XY minus sum of X multiplied by sum of Y divide by square root of N, sorry, sum of XY minus sum of X all square in bracket N, sum of Y square minus sum of Y all square. This is the formula for correlation to determine R, which is the coefficient strength of the relation. Okay, so having got the formula, state a question here for practice using the formula. Now we have this question. I'm going to use the Excel workbook to do this question. Okay, when we get to the formula, then we use this formula. The following data relate to a company. We have month, kilometer traveled, fuel cost. So kilometer traveled, fuel cost is a variable. So the kilometer traveled is an independent variable, fuel cost is a dependent variable. So the kilometer traveled can be X and fuel cost is Y. So we got X and Y already from the formula, right? What is N? N we count 1, 2, 3, 4, 5, 6. So therefore, N is equals to 6. N is equals to 6. Now let's set the table. So now I will use my Excel. I have my X here. Okay. I have my Y. Okay. I have XY as per the formula. All right. Now I will have X square. I will have X square. And I will have Y square. This is what I want. Now for X, I have 2,000, 3,000, 1,000, 4,000. For the sake of calculation, let's keep the 3 zeros. Let's keep the 3 zeros. For X, I have 2, 3, 1, 4, 3, 5. I have my X, value for X. My value for Y. Y, I have 9, 11, 7, 13, 11 again, and 15. I have a value for Y. Now, let's go to the formula. Formula, we need XY. XY. XY simply means X multiplied by Y. So I'm going to use the Excel to do that. X, which is 2, multiplied by Y. And this will give me this figure, 18. And so for all, I will just do drag, and this will give me the entire figure for all. If I check this, 75, you'll see it's 5 multiplied by 15. Gives me 75. Get clear? So now I need x squared. I need x squared. I need x squared equals to, I need x squared. X raised to the power 2. Give me 4. I need all for x squared. And I'll do for same for this. This 3 raised to the power 2. Everything 9. And this again, 1 raised to the power 2. And 4 raised to the power 2, which is 16. And 3 raised to the power 2, which is 9. And 5 raised to the power 2, which is 25. So far, so good, no question, no issue. Right? And for y, same y squared. Y raised to the power 2. So we take this again. For y, this is y9 raised to the power 2. We have 81. And 11 raised to the power 2, we have 121. Okay? And for y, we have 7 raised to the power 2 is 49. And for 13 raised to the power 2 is 169. Are you with me? Use your calculator. You do by yourself, okay? Use your calculator. And 11 raised to the power 2 is 121. And finally, we have 15 raised to the power 2 is 255. We've got the figure. Now, the sum means total them, total. So if I'm going to total this, I'm going to use some formula to total this. Start this one. Then I'll drag, this one from 2 to this one. Close the bracket. Some formula. There's some formula to do this one. It's this. So let's add this plus this plus this plus this plus this plus this equals 18. So this will give me sum of 18. Then I will drag, and I have all my figures now. 796, 64, and 66, 88, 18. So these are my figures. So this figure here is sum of x squared. This figure here is sum of x, y. As you can see, this figure here is sum of y squared. This figure here is sum of y, and this is sum of x. So we have all our figures, right? I have all our figures. This is the other step. First step is state the formula. You identify your variables, split it into 5 tables, x, y, xy, x square, y square. We have what we want. Now let's go with the formula. Now R is equals to the number n. N, remember n we say 6. Sum of xy. Sum of xy is 218. See that? 6 into 218 minus, what's the sum of x? Sum of x, we have it to be how much? 18. And what's sum of y? Sum of y, we have it to be 66. Just go down. We have our roots. And first one, we have here 6 of n. N is 6. Sum of x square. What is sum of x square? Sum of x square become how much? 64 minus sum of x all square. Sum of x all square is how much? Sum of x is how much? 18. So we have 18 all square. Sum of x all square. And come here again. We have our 6. Sum of y square. Sum of y square, we have 796 minus sum of y, 66 all square. Any trouble? Okay. Then we proceed. We move on. 6 multiplied by 218. Calculator. 6 multiplied by 218 will give me 1308. 1308 minus 18 multiplied by 16 give me 1188 divide. Okay, 6 multiplied by 64 will give me 6 multiplied by 64, 384. 384 minus 18 square. 18 square will give me 324. Okay, this close. I'm going to the next one. The next one is 6 multiplied by 796. 6 multiplied by 796 equals 4596. 4596 minus 66 square. 66 square is 4, 4, 3, 5, 6. Close this. Okay, we'll keep going. I think you're getting better now. So 1308 minus 1188. 1308 minus 1188. This will give me 120. Numerator 120 divide square roots. 384 minus 324 gives me 60. And 4596 minus 4356. 4596 minus 4356. This gives me 240. Okay. Keep going. Now, we'll bring our 120 up here. We clear the bracket now. We clear the bracket. 60 multiplied by 240. This will give me the square root of 14. 14,400. 14,400. So square root, to bring the numerator 120. Square root of 14,400. Square root of 14,400 is 120. Therefore, R is equals to 1. This is the answer. So this is how we do correlation. Remember, we can use the same question to do our high-low method. Remember your high-low method. High activity, low activity, find variable cost per unit and multiply by number of units, find your fixed cost and total cost. We can use the same question. Now we use the same question. This is how we do correlation. Correlation, you state the formula. Don't memorize this formula. It will be given to you in the exam. Don't worry about it. It will be given to you. You need to know how to apply the formula, how to use the formula. You don't have to memorize it. Okay, so R is equals to N sigma xy minus sigma x sigma y divided root of N sigma x square minus sigma x all square and N, which is the number, sigma xy square minus sigma y all square. So you set your table like this and you apply your formula using this method. Our advice, you practice this question before we do the next question on correlation. So before coming to the next question, you will have understand the principle, the concept. So this next second question will flow very well. Okay. So take your time, practice this question very well, go over it again, solve it, understand what correlation is about. Correlation is when two variables depend on each other. The one is independent, the one is dependent. Okay. We've seen the demonstration, the positive correlation when they move to the same direction, negative correlation when they move in opposite direction, and the degree of correlation. We have perfect correlation. We've seen the graph, partial correlation, and where there is no correlation at all. And how to determine the strength of correlation, which is the R, the coefficient of correlation, which is R. So how to determine R using this formula, and this is how we go. Okay, see you in the next question. Have a good day. Bye-bye.